Hi guys, and welcome to the video on the area and perimeter of parallelograms. So in this video guys, we're going to be calculating the area and the perimeter of rectangles and parallelograms because buildings are usually designed from rectangles and parallelograms, so if you wanted to do anything with construction, this would be incredibly helpful to know. And you're going to know you're successful when you can calculate the area perimeter of a parallelogram or work backwards. So just remember that the formula for the perimeter of any sort of four-sided shape would just be to add all four sides together. In a parallelogram where opposite sides are congruent, there is a second formula that exists, and that second formula would be 2 times side 1, because the other side, side 2, these are going to be right here, these are going to be congruent, and then these two will be congruent as well, so it would be 2 times side 3 as well. So the formula for the area of a rectangle and for all parallelograms is essentially going to be area is equal to base times height. Any side of a rectangle can be a base, and a rectangle's height is the length of any side that is perpendicular to the base. So the area of the rectangle then is equal to the base times the height. The area of a parallelogram is again the same, but remember that the height here with a little asterisk means that you need to find the altitude of the parallelogram, because despite the fact that you have four sides like that, the height needs to be perpendicular to the base. So just remember that no 90, you might have seen it in the previous video, no 90, no good. If the altitude and the base do not form a 90-degree angle, then that's not really the altitude. This right here is absolutely essential. This is 100% essential. Okay. And then finally, the formula for the area of a rhombus, if you do not know the height, is A equals the diagonal 1 times diagonal 2 divided by 2. And we went over that formula when we covered rhombuses last section. Just reviewing it for you again. So, example, find the area and the perimeter of the parallelogram below. So I remember the area properties of parallelograms states that this side would be 7 centimeters, and then this side up here would be congruent to the opposite side down here of 8 centimeters. So for the area, I could do base times height, and I can tell right here that these definitely make a 90-degree angle. So the area is actually going to be 8 times 4, which means the area is 32 centimeters squared. And remember that all area needs to be units squared. And then for the perimeter here, I'm going to add 1, 2, 3, 4 of my sides, or I can do the formula of 2 times the side 1 plus 2 times side 2. So if I go ahead and put those in, it would be 2 times 7 plus 2 times 8. So that's going to be equal to 14 plus 16. So my perimeter is going to be equal to 30 centimeters. Okay, so there's a basic example for using parallelograms for area and perimeter of those. Find the altitude of a parallelogram that has an area of 7.13 meters squared and a base length of 2.3 meters squared. So what I am going to do is I'm going to go in here and I am going to grab a shape and I'm going to draw a parallelogram really quick, all right, because I'm not the greatest at freehanding it. And we are looking for the altitude, the height, when we know that the base is 2.3 meters. and calculate its perimeter. So the next thing that we're going to need here to find, so it's 2.3 over here. The next thing that we're going to need is we are definitely going to need to calculate the height by reverse engineering the formula of area equals base times height. So the area here, I don't want to write A again. The area is 7.13 and the base is 2.3 times h. So I'm going to divide both sides by 2.3. And then what's going to happen is I'm going to get h on this side. And on the right side of the equation, I'm going to get 7.13 divided by 2.3 is 3.1 meters. So h equals 3.1. And then the base length here, the only thing that I could assume then is that the parallelogram is a rhombus and has all four of its sides congruent, because this is the information that they've given me. I would need some sort of additional information. I mean, I could draw in a second height here. It is totally possible I could draw at a second height here, 3.1 meters in meters. But without some additional information, I would just have to assume that the bases are all the same. So the perimeter would be 4 times 2.3, which means that the perimeter here is going to be 9.2 meters. Okay, I'm going to go put a box around this one as well. Okay, so find the area and the perimeter of the parallelogram below. So I have a base, and I have part of a base here, which means then from here to here, this would be 10 centimeters. And since it's a parallelogram, this over here would be 13 centimeters. So with all of that information in mind, I'm looking for h. But I don't know the area, so the only thing that I can really do, I think about this, and I don't know the area, so really all that I can do is, with knowing that this is the height, I can only really do the Pythagorean theorem to find h. So I'll do 5 squared plus h squared equals 13 squared, because I have leg here, the h will be a leg, and this will be the hypotenuse. So I get 25 plus h squared equals 169. So h squared, I'm going to take away 25 from both sides, equals 144. So I'm going to take the square root, and you get h equals 12 centimeters. Okay, so that's going to go in here. So now I can calculate the area of my shape, so I'm going to do it over here. Remember, area is base times height. The base is 15 centimeters. The height is 12 centimeters. So the area is equal to 180 centimeters squared. And then to calculate the perimeter, I just have to add up all the sides together. Not A. I don't want to draw an A here. The perimeter is equal to 15 times 2, because they've got two sides of 15, plus 13 times 2. So the perimeter here would be 30 plus 26. So then the perimeter is 56 centimeters. Okay, so hopefully you guys are starting to get a hang of how we can do various methods of calculation to find missing sides that allow us to complete our calculations of area and perimeter. So let's take at right here, the figure below is known to be a rhombus. What is its area and perimeter? Okay, so in order to actually calculate the area of a rhombus, I need to make sure that I have both diagonals. Side AC would be the first diagonal, and side BD, started right AC, side BD is going to be diagonal 2. I know that diagonal 1 is going to be 8 plus 8, or 16 centimeters. What I don't know is the measure of diagonal 2. If I could find this measurement here, I could double it to get BD, or add it to itself a second time. We know from last unit that rhombuses have diagonals that intersect at a 90-degree angle. So what I can do is I can do the Pythagorean theorem here again. So x squared plus 8 squared equals 10 squared. So x squared plus 64 equals 100. So x squared equals 36. You take away the square root from both sides, or you do the square root of both sides, excuse me. So x equals 6. So x equals 6, which means if this is x here, that's x there. So finding BD would be 6 plus 6, or it would be 12 centimeters. So what then I can do is use the area formula. A equals the diagonal 1, 16, times diagonal 2, 18, or excuse me, 12, 12, 12, 12, 12, 12, 12, 12, 12, 12, 12, divided by, and that is a terrible, divided by 2. Fix my 6 here. Okay, so then the area would be of this shape. 16 times 12 gives me 192 divided by 2, so 192 on the top divided by 2. So the area is 96 centimeters squared. And because I know this shape is a rhombus, this, and this are all congruent. So to find the perimeter, I can take 4 times the one side length that I know. So that just means that I have a perimeter of 40 centimeters. Okay, moving on. Find the area and the perimeter of the parallelogram on the coordinate plane. So, on a coordinate plane, to count height, you can just go up, and that height would be 1, 2, 3, 4, 5. So I know that the h here is 5. And I know that the base is, if I count it, 1, 2, 3, 4, 5, 6. So the base is 6. So I can simply do base times height. Area is equal to 5 times 6, or the area is equal to 30 centimeters squared. Actually, I can't say centimeters, excuse me. I have to say units, because on the coordinate grid, unless you have a unit, like they tell you each square means a certain unit, all you can say is units squared. To actually calculate the lengths of each side, I know that the bottom side is 6. I know the top side is 6 for the perimeter, but to calculate this length here and to calculate this length here, I need to use the Pythagorean theorem along with the whole height thing here in order to actually get the value of that side. So what I am going to do is I've got a length of 2 here and a height of 5. So I'm going to do the Pythagorean theorem. 2 squared plus 5 squared equals c squared. And we're going to call this c out here. So I get 4 plus 25 equals c squared. So 29 is equal to c squared. and taking the square root. During this unit, guys, it is okay to use decimal approximations because we don't need to be that precise. So C equals 5.4 when we round it. The actual answer I got was 5.38, so we're going to round it to 5.4. So this side over here is 5.4, and this one over here is 5.4. So if I do the perimeter formula for a parallelogram, P is equal to 2 times 6 plus 2 times 5.4. The perimeter is going to be equal to 12 plus 10.8. So the perimeter is 22.8 units because it's the coordinate grid. All right, find the area and the perimeter of the rectangle on the coordinate plane. So what's really nice is on a coordinate plane, I know that these right here form a 90-degree angle. However, to actually find the length of AB and the length of AD, I am going to need to use the Pythagorean theorem again. Because they're slanted, and as long as a shape is slanted on, or a line is slanted on the coordinate plane, you can't just count length, you actually have to calculate it. So I'm going to draw fictional sides here for my triangle. Up 3 and over 4. 3 and 4 here. So then I can do the Pythagorean theorem here. 3 squared plus 4 squared equals AB squared. So I get 9 plus 16 equals AB squared. And go over here. That's 25 equals AB squared. So you take the square root, and AB is going to be equal to 5. So this length here is 5. And then I'm going to do the same thing to find AD. So I'm going to go down. I want a little pass where D goes to. And then I'm going to go over. So I'm going to count squares. 1, 2, 3, 4, 5, 6, 7, 8. So this has a height of 8 and has a 1, 2, 3, 4, 5, 6. Length of 6 this way. So to calculate AD, it's going to be 6 squared plus 8 squared equals AD squared. So then I get 36 plus 64 equals AD squared. So 100 equals AD squared. Take the square root of both sides. 10 equals AD. So I've got 10 here. And that's perfect then, because then this side over here, since it's a rectangle, also is 10. And then this side here, the 5, is congruent to this one down here. So now I can do the simple formulas of area is equal to base times height. And I can do the perimeter is equal to 2 times side 1 plus 2 times side 2. So the area is equal to base times height. The area is equal to 5 times 10. So area is equal to 50 units squared. And then for the perimeter, I'm going to put in 2 times 5 plus 2 times 10. So I get 10 plus 20, which is 30 units. So that's how to find area perimeter for something that's all slanted on a coordinate plane. Use the Pythagorean theorem a couple times, and then do the calculations as normal. And then finally, if you're given coordinates, calculate the area and perimeter of the shape. So I'm going to locate the coordinates. E equals -1, 5. F is equal to 2 and 8. So I can draw in my line there. H equals 1, 1. And G equals 4, 4. Okay, so to calculate the area in the perimeter, it's the same formulas that I've used before. Area is equal to base times height. Perimeter is equal to side 1 times 2 plus side 2 times 2. So to calculate those lengths, we need to do the Pythagorean theorem here. So we're going to go up here and over this way, and I've got a 3 and a 3. So if I quick do the Pythagorean theorem, because this video is starting to get on in length, EF squared will be equal to 3 squared plus 3 squared. So EF squared is going to be equal to 3 squared and 3 squared. Each one of those is 9. 9 plus 9 is 18. So I take the square root of both sides. EF will be equal to the square root of 18. And the square root of 18 is about 4.2. And then I'm going to go over here, and it's a side of 2 and a side of 4. So FG is squared is going to be 2 squared plus 4 squared. So I get FG squared is going to be equal to 2 squared is 4 plus 4 squared is 16. 4 plus 16 is 20. So we'll take the square root of both sides. So FG is equal to the square root of 20, which the square root of 20 is about 4.5. So then this and this are congruent, this and this are congruent. So then let's just go ahead and multiply them out. So the area is going to be equal to 4.2 times 4.5. So 4.2 times 4.5 gives you an area of 18.9 units squared. And for the perimeter, you're going to put those in as 4.2 times 2 plus 4.5 times 2. So the perimeter here is going to be 8.4 plus 9. So the perimeter is 17.4 units squared. Units, not units squared, perimeter, units. Alright guys, so sorry about the length of this one, but in summary, the formula for the area of parallelograms is base times height, but these measurements must form a 90-degree angle. The formula for area of a rhombus is different if you don't know the base or the height. And then remember, the basic formula for perimeter is to add all the sides together. And on a coordinate plane, make sure you don't forget to use the Pythagorean theorem to find missing side lengths. So that's it for today's video, guys. Thanks for watching, and I'll see you in the next one.